Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. I encourage you to subscribe to our channel if you have not, and like our videos if you go on to enjoy them. And if you know anybody that these videos can be useful to, the topics we've covered so far and topics we're going to cover, please share the link to them and let them know that something is happening here. We want everybody to pass maths. I don't want to see people fail maths. In this video, we're looking at area of circles and area of sectors and segments of circles. This is a follow-up to one of the videos that we did before. We talked about length of arcs and perimeter of sector and perimeter of segment. So if you have not watched that, I would encourage you that you actually watch it, because we're going to be applying a lot of principles from there in this video. So without further ado, let's get started. We've talked about area before. That is the space a shape covers measured in square units. Two-dimensional shapes, talk about the area. For three-dimensional shapes, talk about the surface area. These are things that we've established in previous videos to this, on the two previous videos to this. We've talked about this diagram. We said this small square is representing the space that covers inside this big grid of squares. So it covers 4 grids of squares. So basically, a circle is a set of all points in a plane that are equidistant from a fixed point called the center. Basically, you're coming from the center, and then all around the center, every point from that center is equidistant. That means that they have the same distance. So when you do that, you have a circle. The common distance from the center to any point, so if I'm coming from the center to any point on that circle, is called the radius. So you can see this is the circle, this is the center of the circle. From here to any point on that circle, from here to here, here to here, here to here, is the radius. Now you see this line that's called D. Look at this, is from here to here, which is one radius. This from here to here, this is another radius. So radius plus radius, that's 2 radius. And we know that if you have the total length, which is made up of 2 radius, we're talking about the diameter. So diameter is 2 times of the radius. So a sector of a circle is the region enclosed by 2 radii and the arc between them. I know you've eaten pizza before, so imagine somebody's coming from Domino's Pizza, right, and the person bought a pack of pizza. Everybody wants to circle around and take a piece. That piece that you take, you see that there is a radius, and there's a small arc. It forms like a triangle, but it's not really a triangle because of the arc at the bottom. That is basically a sector of a circle. While a segment is the region that is enclosed by a chord. We talked about the chord before, and the arc between the chord's end points. We said a chord is just any line that connects 2 points on a circle. So even the diameter is a chord, but the diameter is the biggest chord in a circle. So you can see the sector just like your slice of pizza. This is like the arc, this is like the chord, and this is the arc between the chord end points. So this is the segment, this is the sector, and this is the full circle. Now we're going to look at area of circle, sector, and segments. The formula, basically. Formula of the area of circle is pi r square. If you have a circle and you want to find the area of a particular sector, remember the sector just takes a portion. So if this is a circle, the sector just takes a portion here. So we just want to find what is the area of this portion. Remember, the total angle in a circle is 360. So we want to find the area of this small portion. So we have to find the angle that small portion subtends, which is theta, all over the total angle in a circle, which is 360, times the area of a circle. Then we know the portion of just this small part. Once again, just find the angle that the sector subtends all over the total angle of a circle and multiply by the area of a circle. That will give you the area of this small part. So the area of the segment of a circle is the area of sector minus the area of the triangle formed by the chord and the 2 radii. What do they mean? So if these are circle and we have this chord, right? These are chord. If I draw this small place here, this place is my segment. I want to find the area of this segment here. I can find the area of this entire chord. This entire chord. If I find the area of this entire chord and I subtract from the area of this triangle here, this place here, it will give me these remaining parts. You agree with me? Great. So just like I said, this is like your sector. If you take out this triangle here, it it will give you the area of the segment. So example 1 states that a sector of angle 120 degrees is cut out from a circle of radius 13.5 centimeter. What area of the circle is remaining? And let's take from NECO 2008. We should take pi to be 22/7. I want you to at least try your hands on this and pause the video and try it out yourself. Welcome back. Let's look at it together. So we have a circle, and they said a sector of 120 degrees is cut out from the circle. So let me just say something like this. This is the center of the circle. So this angle here will be 120 degrees, right? It now says what area of the circle is remaining. So if this 120 degrees is cut out, we know that the area in a circle is 360. So we could say that the remaining angle would just be 360 minus 120 degrees, and that will be equal to 240 degrees. So this angle here is 240 degrees. So there are two ways we can solve this. We can solve the area of the circle using just this 240 degrees, or we could find the area of the full circle and subtract the area of the sector from it, and we'll have the area of the remaining. I will do the two ways. So I'll just say option 1. I will use this 240 degrees because that's the area of the circle, or the angle of the circle that is remaining. So our area of the remaining circle will just be theta over 360 times pi r squared. If you look at it, this is also the formula for a sector, right? Because this part here is the major sector, this part here is the minor sector. So as I've taken one part of it, the remaining part is also a sector too. So if I substitute, this would be 240 over 360 times 22/7 times 13.5 all squared. So we could just cancel out and say 4 here 6, 4 here 9, right? I think that's the thing that can go. So that would be 6 times 22 times 13.5 squared divided by 9 divided by 7. So this gave me 381.9 centimeters squared if I do it to one decimal place, and which is option D. So this is the option 1. So for our option 2, we're going to find the area of the full circle, which is pi r squared, and that will be 22/7 times 13.5 all squared. So 22 divided by 7 times 13.5 squared, that gave me 572.7, let me just say 79 centimeters squared, right? So I have the area of the full circle, so I will not do the area of this small sector. So the area of the small sector would be theta over 360 times pi r squared, which would be 120 over 360 times pi r squared. We've already done this here before. I've gotten 572.79. This 120 here 1, 120 here 3. So if I divide this by 3, this gave me 190.93 centimeters squared, right? So now we have the area of the full circle, we have the area of the small sector. So the area of the remaining sector will just be area of the full circle minus the area of the small sector. So that will be 572.79 minus 190.93. So 572.79 minus 190.93. Yeah, so this gave me 381.86 or 81.9 centimeters squared. So any way that you choose, right, this is simpler, but any way that you choose, it all depends on how you understand the question. The most important thing is that you get the answer and you get it in a very fast way, especially when you're dealing with something like JAMB where you are being timed. I think WAEC is going to be CBT very soon, right? So you want to use the most efficient way to solve a particular question. So our answer is option D. Let's see if we're correct. Great. Example 2 now states that the diagram below, okay, theirs is above, ours is below, shows the shaded segment of a circle of radius 7 centimeter. If the area of the triangle OXY is 12 1/4 centimeter squared, calculate the area of the segments, and this taken from WAEC 1992. Take pi to be 22/7. We are given the options. I want you to pause the video and try this out yourself. Welcome back. Let's look at it together. So we know that the area of the segments is the area of the chord minus the area of the triangle. We've established that before. So what is the area of the chord? Area of the chord is theta over 360 times pi r squared minus area of the triangle. We are giving the area's value. So this would be, the theta there is 30 degrees. That would be 30 over 360 times 22 over 7 times 7 squared, because the area is 7 squared, minus 12 1 over 4. That's 4 times 12 is 48 plus 1. That will give you 49 over 4. So this will go and this will remain 12. This will cancel one of this. 2 here 6, 2 here 11. So this will be 11 times 7 is 77 over 6 minus 49 over 4. So the LCM here is 24. 24 in 6 is 4. So 4 times 77, that gave me 308, minus 24 in 4 is 6. So 49 times 6, that gave me 294. So 308 minus 294, that gave me 14. So 14 over 24, 2 here 7, 2 here 12. So the answer here is 7 over 12 centimeters squared, and that will be option B. So I did it in all this fraction because I know that the answers were in fraction, so answer should be option B. Let's see if we're correct. Great. Example 3 says that a sector of a circle of radius 7 centimeter has an area of 44 centimeters square. Calculate the angle of the sector correct to the nearest degree. Take pi to 22 over 7. And take from WAEC 1990. I want you to pause the video and try this out yourself. Welcome back. Let's get it together. So we're told that in this question the radius is 7 centimeter, the area is 44 centimeters squared, and we're told to find theta. So the area of the sector is theta over 360 times pi r squared, and that will give me 44 is equal to theta over 360 times 22 over 7 times 7 squared. So 1 over 7 comes 1 over 7. I don't, let me not confuse anybody, so I'll just do it one at a time. 2 here 11, 2 here 180. So this would be 44 is equal to 11 times 7 over 180. So if I cross multiply, also times theta, if I cross multiply, that will be 180 times 44 is equal to 11 times 7 times theta. If I divide both sides by 11 and this side by 11, 11 cancel 11, 11 here 1, 11 here 4. So our theta is basically 180 times 4 all over 7. And that gave me 102.857 degrees. But they told us that we should do it to the nearest degree, so which is approximately, this is 8, so it will be 103 degrees. So to the nearest, let me just swipe this up, to the nearest degree. Great, and that should be option D. Let's see if our answer is correct. Great. Example 4 says that the area of a circle is 154 centimeters squared. It is divided into 3 sectors such that 2 of the sectors are equal in size. Pause and reflect on that. Great. And the third sector is 3 times the size of the 2 put together. That means the other 2. So we have the third, which is 2 times the size of the other 2 put together. And told that we should calculate the perimeter of the third sector. This question is taken by 2013, and we say we should take pi to 20 over 7. I want you to pause the video and try this out yourself. Welcome back. Let's get it together. So imagine this as a circle, and we're told that it is divided into 3 sectors. So that will be something like this: 1, 2, and 3. Right? So 1, 2, 3. It now says that 2 of the sectors are equal in size. So let's say this is x, this will be x because they're equal in size, and the third is 3 times the size of the other 2. So the third sector is 3 times x plus x, the other 2 put together, and that will be 3 times 2x, which is 6x. So that means this angle here is 6x. It now says that calculate the perimeter of this third guy, this biggest one. So we can find x because 6x plus x must be equal to 360 degrees, right? Because the angle in a circle is 360. So 6x plus x is 7, that is 8x is equal to 360, and divided by both sides by 8. What does that give me? 360 divided by 8 would give you 45. So x is equal to 45 degrees. So that means that therefore the angle of the third sector which is equal to 6x, right? This would now equal to 6 times 45. And what would that give you? That will give you 270. So the angle of the third guy is 270 degrees. Great. So we know this guy. Perimeter of the sector, what do we say it is? It is, we have the radius plus radius, that will be 2 radius plus this arc, right? Which is the length of arc. That will be 2r, and our length of arc, we said is what? Theta over 360 times 2 pi r in that previous video to this. I think maybe the last 3 videos to this. So we know our r. Where's our r? Our r is oh, so we don't even know the r. We have to find the r, but we're told that the area of the circle is 154 centimeters square. So from that information we can find r. So if area is 154 centimeters square, which is equal to pi r squared, so this would be 154 is equal to 22 over 7 r squared. So if I cross multiply, r squared is equal to 154 multiplying by 7 over 22. So this would be 154 multiplied by 7 divided by 22. So this is 49. So the r squared is 49 centimeter squared, basically. Then the r will now be square root of 49, which will give me 7 centimeter. So my r is 7 centimeter. So I can come here and say this is 2 times 7 plus theta is 270 over 360 times 2 times 22 over 7 times 7. So 7 cancel 7. This will cancel this. 2 times 7 is 14 plus 9 here 3, 9 here 4, 2 here 1, 2 here 2, 2 here 1, 2 here 11. So 3 times 11 is 33. So this give me 47 centimeter because it's perimeter, right? Perimeter is just a unit length. So our perimeter here is 47 centimeter. That is the perimeter of this big sector. Let's see if our answer is correct. Great. Example 5 now says that in the diagram A, B, C, D, E, O. So we have A, B, C, D, E, O is 2/3 of a circle center O, right? AO is 7 centimeter and AB is equal to BC is equal to CD is equal to DE. In other words, I should calculate and correct to the nearest O number the area of the shaded portion. Take pi to be 20 over 7. This is taken from WAEC 2006. I want you to pause the video and just try it out yourself. Welcome back. Let's look at it together. So the first thing that strikes me is that if this guy is equal to this guy is equal to this guy is equal to this guy, this guy is radius, this guy is radius, this guy is radius, this guy is radius, this guy is radius. So all this angle here, they're going to be equal. And if I extend this place here, you see that the circle was actually cut into 6 different places, 3 at the top, 3 at the bottom, meaning that all these guys here are going to be equal. If this guy is equal, this guy is equal, this guy is equal, this guy, basically all these guys are going to be equal. So each of the angle would be 360 degrees divided by 6, which is 60 degrees. So this guy here 60, 60, 60, 60. So if I find the area of the segment of one place and I multiply it by 1, 2, 3, 4, I think I should be able to find the area of the shaded portion since they are all similar. Do you agree with me? Great. So we know that the area of the segments is the area of chord minus the area of triangle, right? So the area of the chord here is theta over 360 times pi r squared. So let me just take it one by one. So this would be 60 over 360 times 22 over 7 times 7 squared. This will cancel this. 60 here 1, 60 here 1, 60 here 6, 2 here 3, 2 here 11, So this is 77 over 3 centimeters squared, right? The area of triangle, for this triangle we have the angle between them and we have two sides, so I could use our half AB sine theta, right? We've talked about this plenty times. So this is half times this guy is the radius, that was 7 times 7 times sine 60. So that would be 7 times 7 times sine 60 divided by 2, and that is 21.22 centimeters squared. So the total area of the shaded portion, which is area of the chord minus area of the triangle, would be 77 divided by 3, that is 25.67 minus 21.22. so this is minus 21.22. this gave me 4.4, basically 45 centimeters squared. This is the area of one shaded portion, one of them. So total area of the shaded portion would just be, how many of them do we have? 1, 2, 3, 4. That would be 4 times 4.45. so if I multiply this by 4, this gave me 17.79 centimeters squared. So these are approximately 18 centimeters squared to the nearest whole number, because that's what they said we should do it. Let's see if our answer is correct. Great. I hope you understood what really happened there. If you look at this, you will know that all of these guys are equal. And if they're equal, and if you even draw the full circle, you see that it's divided into 6 equal parts. So just find the area of one and multiply by the amount that you have, and you'll be good. Example 6 says that a circle has radius x centimeter. What's the area of a sector of the circle with an angle 135 degree, leaving the answer in terms of x and pi? This is taken from 2008. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So the area of a sector is theta over 360 times pi r squared. Theta is 135, right? So all over 360 times pi times the radius is x, so this x squared. So 135 divided by 360, if you cross and cross and cross everything, so that this will give you 3, this will give you 8. You can try that yourself. So we should just do in terms of x and pi, so that would be 3 pi x squared all over 8. I hope you got the same thing that I got, and I hope we're both correct. Let's see if we're correct. Is it option D? It looks like it, but this is meant to be x squared, so you have to be very, very careful of the options. Our answer is actually option B. Great. Example 7 says that the length of an arc of a circle of radius 5 cm is 4 cm. Find the length of the sector. This is from WAEC 1998. I want you to pause the video and try this out yourself. Welcome back. Let's look at it together. So the length of arc is 4 cm. The radius is 5 cm. I'm told to find the area of the sector. Length of arc is, what do we say length of arc is? So this is a circle. Let's just say this is one small place. This place here is the arc. What do we say the formula for length of arc is? Not length of chord or length of segment though. Length of arc is theta over 360 times 2 pi r. Only is when you are doing length of chord, I now say 2r. R plus r, you now say plus 2r. Or when you are doing length of segment, you now say plus length of chord, like plus length of chord. Don't confuse it. So let's substitute. Length of arc is 4, so that is 4 is equal to theta over 360 times 2 times 22 over 7 times 5. So this will be 4 is equal to 2 times 22 times 5 divided by 360 divided by 7. This gave me 11 theta all over 126. So if I cross multiply, this 11 theta is equal to 126 times 4. So 126 times 4, that's 504. So 11 theta, if I divide both sides by 11, my theta would be equal to 45.82 degrees basically. So my area of sector, which is theta over 360 times pi r squared will just be 45.82 divided by 360 times 22 over 7 times 5 squared. Let's see what that will give us. That will be 45.82 divided by 360 times 22 over 7 times 5 squared. So this gave me approximately 10 centimeter squared. So our area of sector for this particular question would be option D. Let's see if we are correct. Great. So we've come to the end of this particular video on area of circle, sector, and segment. I hope you found it useful, and if you found any of those length things strange, just go and watch the video on lengths of arc, perimeter of segment, and sector, and you'll be fine. I'll see you guys in the next video. Bye for now.